Alright, in this video we're going to discuss how to conduct a chi-square test for independence. And I'm going to do this using an example where I have families that have told me the number of children they have in their family and their self-reported level of religiousness. So they're either religious, semi-religious, or not religious, and they either have 0 kids, 1 kid, 2 kids, 3, 4 kids. Okay? And what we want to test here, our null hypothesis, is going to be that the number of children is independent of religiousness. Okay, so number of children is independent of religiousness. Okay, and independent is always going to be the null hypothesis. The alternative hypothesis, H1 or HA, is going to be the dependent side. So the number of children is dependent on religiousness. Okay. All right. Just to kind of remember, what does independent mean? What does that mean? If you remember back when we learned about probability, 2 events are independent. Okay, so say the number of children that you have is event A, and your religiousness is event B. A and B, the probability of A and B equals the probability of A times the probability of B, okay, if A and B are independent. Okay, and so that is basically what we are testing here. We are testing, is the probability of A and B equal to the probability of A times B? Okay, so this is what we observed. This is our data that we observed. Let me highlight that. What we need to do is we need to construct a table that looks just like this, except it is for it's what we would expect if this probability of A times B, if that's true. Okay, so if the null hypothesis is true. Let me delete this. So I'm going to take this table, I'm going to copy it, and I'm going to paste it here. Okay, actually, let me paste it one more over. Okay, give myself enough room here. Okay, so this is, instead of observed, I'm going to want this to be the expected. Okay, and let me delete all the data from this table, because we're going to calculate what we would expect if this probability statement here about independence, if that holds true. Okay, so in order to calculate these expected, first thing I need to know is basically, so starting with the probability of A, right? What is the probability of having 0 kids in this table here? Well, first thing, let's figure out how many people are in this, or how many families are in this data. So let's add up all of the data. Now you see what I just did? I typed in sum, and then I added it all up by just clicking and highlighting all the data I wanted to sum up. Okay, so that's B6 to F8. Okay, so click, drag, click it all. Okay, close parentheses and press enter, and we get 46. Let me highlight that. So that's my sample size. So what's the probability of having 0 kids? Well, let's see. We have 2 plus 1 plus 4, so that's 7. There's 7 out of 46. So I could type that as equals 7 over 46. 46. And that's the probability of having 0 kids, right? I can make it into a percentage if I want. By just pressing this little percentage button here, okay? Doesn't matter, I could leave it as decimal, that's fine as well. Now, I could add these all up. It's going to take time. So instead of writing 7 like that, let's write it as the sum. So let me delete what I had. Equals sum. And let me add up 2, 1, and 4, right? So basically click and hold that column. Close the parentheses. Don't forget to close the parenthesis. And then divide by 46. And then press enter. And I get the same number, 15. Okay. So get your little cross to look like a black cross. Click, hold, and drag, and it will calculate the probability of having 1 kid, the probability of having 2 kids, the probability of having 3 kids, the probability of having 4 kids. All right. Now do the same thing for religious status. What's the probability of being religious? So sum up that row. So B6 to F6, right? B6 to F6, right? Just click and hold all the data I want to sum up. Close parentheses and divide it by my sample size, which is 46. Okay. Get your little cross to look like a black cross. Click and hold. Drag it down. Okay, make them look like a percentage by going up here and pressing this little percentage sign. Okay. So 46% of my families are religious, 20 are semi-religious, and 37 are not religious. Okay. Okay. So now I can calculate for each of these what I would have expected. Okay. So starting with 0 children equals that 15% times that 43%. Right? So the probability of being religious and having 0 children is the probability of being religious times the probability of having 0 children, right? Then multiply that by your sample size. So this is the probability, and then times it by your sample size, which is 46. Okay, so we would have expected to have seen 3 families in this category if my data were independent. All right, and we have to do the same thing for each for each cell here. So being this 15 times, now semi-religious is times 20. Okay, and then I'm going to multiply that by 46. Instead of typing out 46, I'm just going to click it. Okay. Equals, this last one is 15 times 36 times 46. Okay. And I can just keep on doing this. So now it's 1, so it's 17 times 43 times 46. Right? There is a shortcut way of doing this. So let me discuss that. So instead of doing 46, let me do this. So what we need to do is we need to lock certain things as we're going. You can just keep on doing it the way I was just doing it. But if you lock, okay, so for this row, we always want it to be this B15, right? So if I were to scroll down, I want it to always be B15. So I need to lock that 9. Okay. Then I want this number to go down, so I need to only lock the G. And then the G and the 9 need to get locked. Okay, so this $ locks it. So press enter, and now I can see if I get my cursor to this black X. Okay, it stays. You see, it didn't change anything. But now the formula, if I highlight all 3 of these items here in this column, get my black cross, and scroll it over, it fills it in all automatically for me. And I can check it by clicking on some of them. Okay, so you see I locked the row number, and then I locked the column number, and then I locked both the row and the column. All right, like I said, you don't have to do it like that. You could have just gone through and done 15 times 43 times 46. 17, times 43 times 56 if you're going this way, right? Okay. Once you have this expected column, now we're almost done, because if I want to find my p-value, all I need to do is type in chi squared CHISQ.TEST, open parentheses, and now highlight all my actual data, comma, and then highlight all my expected data. Close parentheses and press enter. Okay, so my p-value, it's very large, 0.8. That's higher than any alpha that I would choose, any level of acceptable type 1 error. So with a high p-value, I'm going to fail to reject the null hypothesis. And I'm going to say that there's not evidence here that the number of children is dependent on religiousness. Okay, so there's not enough evidence here that the number of children is dependent on religiousness. So I failed to reject the null hypothesis that they are independent of each other, that religion and number of children are independent. Okay, and one last thing, if you wanted to calculate your test statistic, you could. I'm just going to do it really quick. So if I wanted to calculate my test statistic, what I would do is I would type in a formula. So I would do equals, open parentheses, okay, observed minus the expected, close parentheses, square it, divided by the expected. Press enter, and then drag down, and then drag all the way across. Okay, now the total sum, the sum of everything in that table, that's our test statistic. So this is your test statistic, and then you could have done your p-value using that test statistic as well. CHISQ.DIST.RT, and X is that test statistic. All right, and then my degrees of freedom is the number of rows that I have, which looks like I have 3 rows, so that minus 1, so that's 2, times the number of columns that I have. Looks like I have 1, 2, 3, 4, 5 columns. 5 minus 1 is 4, so 4 times 2, right? So basically take your number of minus 1 from each and see how many observations. So you have 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. Oops, accidentally. So just type in 8. So your test statistic, and then the number of rows minus 1, the number of columns minus 1. So this is 4 times 2, which is 8. Close parentheses and press enter. And you should get the exact same p-value that we calculated when we just used the CHISQ test, which we do.